In a school, there are two sections, section A and B of a class 10th. There are 32 students in section A and 36 students in section B. Determine the minimum number of books required for their class library so that they can be distributed equally among the students of section A or section B. So in section A, number of students is equal to 32, and in section B, number of students is equal to 36. Let the number of books in the library be X. So X books in the library. Now these X books have to be distributed to 32 students. That means X has to be a multiple of 32. Let me explain that. Suppose this is the library and there are X books here. These X books have to be given to all, distributed to 32 students. So you'll definitely agree that X has to be a multiple of 32. And the same books X have to be also distributed equally among 36 students. So 36X should also be a multiple of 36. So the number X should definitely be more than 32 and more than 36, because if it is less, how will all the students get the books? So here X is a multiple of 32 and X is also a multiple of 36. So we write that X is a multiple of 32 and X is also a multiple of 36. So therefore X is LCM. Multiple means LCM. X is the LCM of 32 and 36. So we need to find the LCM of 32 and 36. 32 is 2 raised to 5 and 36 prime factorization 2 raised to 2 into 3 raised to 2. Now when we find LCM, I'll do it here. To find LCM, we write all factors with their highest power. So the factors here are 2 and 3. The highest factor power of 2 is 5 and the highest power of 3 is 2. So LCM equal to 2 raised to 5, 3 raised to 2, which is 32 into 30 into 9. 3 raised to 2 is 9. So the answer is 288 books. So the number of books should be 288. So let me explain the meaning of the sum. So we said in this library they have to be 288 books. Now if these books were to be distributed in section A, there are 32 students in section A. How many books will each student get? So each student would get 288 over 32, and that would be 9 books. Each child would get 9 books. Now if the same library, you know, there are 288 books we have bought, and now this is to be distributed in section B, the same books. There are 36 students. So each student will get 288 over 36, and that would be 8 books each. So this is what they had asked us. They had asked us find how many books. We said first the books were X and X. And now you know why you found the LCM. If the books have to be distributed, this X should be definitely greater than 32 and this X should be greater than 36. And X should be a multiple of 36 and a multiple of 32. So the X that we found was the LCM, and we got it as 288. Here also we got it as 288 books. Prove that 1 over under root 2 is irrational. So we'll say we assume 1 over under root 2 as rational. And if it is rational, we'll say 1 over under root 2 equal to P over Q, where Q not equal to 0, cross multiply, and we get Q over P equal to root 2. Now if we take up the right hand side, Q and P both are rational numbers. Therefore the right hand side, Q over P is also rational. Now when we take the left hand side, root 2, we know root 2 is irrational. Now this is not possible. A rational number cannot be equal to irrational. Rational is not equal to irrational. Therefore, assumption is wrong. So we must say that 1 over under root 2 is irrational. We assumed it was rational, it must be irrational. Find the largest number which divides 245 and 1029, leaving remainder 5 in each case. Let me write this. So we say let the number be X. So that means when I divide 245 by X, I get a remainder of 5. And when I divide 1029, here they say leaves remainder 5. Divide by X, I get a remainder also 5. So definitely X is not a factor of 245 because you get remainder 5. So X is factor of 245 minus 5, which is 240. So that's what I'm going to write. X is factor of, before that we could write when 245 is divided by X, remainder is equal to 5. Therefore, X is factor of 245 minus 5, which is equal to 240. Let's write again. X is factor of 240. For the next part, we have 1029 when divided by this number X, say largest number that divides, right? Here leaves remainder 5 here also. So we write that 1029 is divided by X, and in this case the remainder is 5. Therefore I can say X is factor of 1029 minus 5, that is 1024. So x is factor of 1024. Now this part is important. X is a factor of 240. X is also a factor of 1024. So x is a common factor of both of 240 and of 1024. So we find x will be, if we want the largest number, so x is HCF of 240 and 1024. So to find this answer, we have to find the HCF of 240 and 1024. So prime factorization of 240 will do, that is 2 raised to 4 into 5 into 3. And then prime factorization of 1024 is 2 raised to 10. We need to find HCF. So for HCF, we write common factor and lowest power. So common factor here is 2, the lowest power is 4. So HCF equal to 2 raised to 4, which is 16. So the largest number that divides 245 and 1029, leaving remainder 5. In each case, is 16. Let's just check up and see if it's correct. Let's take up 245 and divide by 16. And if you do this division, you'll see you get here 15. I'll do the division straight on. You'll get 240 and we'll leave remainder 5. Similarly, if you take the number 1029 and you divide it by 16, here you get 64 and it's 1024. You've got to do the long division. I've just taken shortcuts, and here you get the remainder 5. So it's right. When it's divided, the number is 16. 16 divide 245, remainder 5, and 1029 divide 16, remainder 5. So in the sum, you have to take the HCF. A shopkeeper has a 120 liters of petrol. So let me draw 120 liters. So that would be like, maybe I'll put it here. This is 120 liters. Then he has also 180 liters of diesel. So it's a little bigger. 180 liters, and this is diesel. This was petrol. And 240 liters of kerosene. That's even larger. $240 liters of kerosene. Now he wants to sell oil by filling the 3 kinds of oils in tins of equal capacity. What should be the greatest capacity of such a tin? So he wants to make these little tins and fill the petrol, fill the diesel and kerosene in this tins. So let the capacity of this each tin be X liters. So he's going to take up this 120 and he's going to divide it into these small X. We don't know how many, X and X. So you definitely know X is factor of 120. Then he takes the diesel and also packs it up in many little tins. We don't know how many, but we know each tin has capacity X. He pours this in different tins of X, X and X. So again, X is also a factor of 180. Last is time for him to pack his kerosene up. So that also he splits it into many tins, and each tin we know we have taken this as X. So X should also be factor of 240, which means now X is a common factor. X is common factor of 120, 180 and 240. So in the sum we have to find HCF of 120, 180 and 240. So now we need to find HCF of 120, 180 and 240. So we take 120, prime factorization of 120 is 2 raised to 3 into 3 into 5. Then 180 is 3 raised to 2 into 2 raised to 2 into 5, and 240. 240, 2 raised to 4, 3 into 5. To find HCF, we write common factor and lowest power. And if you see the common factor here, 2 is here, 2 is here, 2 is here. And the lowest power of among these twos is 2 raised to 2. Then also 3 is common. See here, we have 3 here, 3 here and 3. Lowest factor of all these 3 is 1. And then we have the 5. 5, 5 and 5. 1. So HCF will be 2 raised to 2, 3 raised to 1, 5 raised to 1. That is 4 into 3 into 5, which is 60. So this can has to be made of 60 liters. The capacity of the can is equal to 60 liter, which means now the 120, when it is divided, it will be made into 2 cans. It will be 60 here and 60 here, the petrol, 2 cans of petrol. When it comes to diesel, you get 3 cans, 60, 60 and 60. And when it comes to kerosene also, you will get now 4 cans, 60, 60, 60 and 60. So the cans that he has to make or manufacture is of 60 liters. Express 3825 as a product of the primes. So we have 3825. We divide by 5, so this becomes 765. This again will divide by 5 and it will be 153. Now 153 is divisible by 9 and 17. So 3825 is equal to 5 square, 5 into 5, 9, I will put 3 into 3 square. I should have done 3 square there, into 17. So this is the prime factors of 3825. Find LCM and HCF by prime factorization. So prime factorization of 8, 2 raised to 3. Prime factorization of 9, 3 raised to 2. And prime factorization of 25, 5 raised to 2. Now to find HCF, we do common factor and lowest power. And if you see here, there is no common prime factor, but you could put it into 1, into 1. This is just factorization. So common factor 1, lowest power 1. So HCF equal to 1. To find LCM, we do all factors and highest power. So factors are 2, 3 and 5. Highest power of 2 is 3, then of 3 is 2 and 5 is 2. So we have LCM 2 raised to 3, 3 raised to 2, 5 raised to 2, which is 8 into 9 into 25. So the LCM is 1800. Find the HCF and LCM of 6, 72 and 120. So for 6 I do 2 into 3. 72 you'll get 2 raised to 3 into 3 raised to 2. You do the prime factorization, you'll get this. 120, 2 raised to 3, 3 into 5. To find HCF, we write common factor and lowest power. And you see the common factor here is 2, 2, 2. The lowest power of all the 2's is 1. And then the next common factor is here 3, 3, 3. And the lowest power again is 1. So HCF equal to 2 raised to 1, 3 raised to 1, which is equal to 6. Now to find LCM, all factors and highest power. So all factors 2, 3, 5. Highest factor of 2 is 3, of 3 is 2 and 1. So you have LCM 2 raised to 3, 3 raised to 2 into 5. That is 8 into 9 into 5, which is equal to 360. So LCM is 360. State whether 29 over 243 is terminating or non-terminating. So we have 29 over 343. We have to prime factorize the denominator. So 29, this is 7 into 7 into 7. So 29 over 7 raised to 3. Thus the denominator is not in the form of 2 raised to m, 5 raised to n. There is no 2, there is no 5 in the denominator. So therefore it is a non-terminating repeating decimal. There is no 2, there is no 5. State whether 23 over 2 raised to 3, 5 raised to 2 is terminating or non-terminating. We can do it orally because they have already factorized and given us the denominator. So here, so you see the denominator is in the form of 2 raised to m, 5 raised to 2 or n. So we can write denominator is in the form of 2 raised to m, 5 raised to n, means 2 raised to 3, 5 raised to 2. So it's got factors 2 and 5. Therefore 23 over 2 raised to 3 into 5 raised to 2 is a terminating decimal. Find the LCM and HCF of 336 and 54 and verify that LCM into HCF is product of two numbers. So we have 336 prime factorization of 336 is 2 raised to 4 into 3 into 7, and then of 54 is 3 raised to 3 into 2. So to find the HCF, we do common factor, and the common factor are 2 and 3 and the lowest power. Of 2 is 1, of 3 also is 1. So HCF equal 2 raised to 1, 3 raised to 1, which is 6. And then for LCM, all factors and highest power. So all factors 2, 3, 7, highest power 4, highest power of 3 is 3, highest power of 7 is 1. Have you seen here 7 raised to 1? So here 3, this is the highest power of 3, this is the highest power of 4. So LCM 2 raised to 4, 3 raised to 3 into 7. 2 raised to 4 is 16 into 27 into 7. And when you multiply this, you get 3024. Now for the next part, we have to find the LCM into HCF, the product of LCM and HCF. And that is 3024 into 6, which is equal to 18144. And this is product of numbers. And the numbers are 336 into 54, which is also 18144. So it is equal, the LCM into HCF equal to product of numbers. Prove that 7 under root 5 is irrational. So we assume 7 under root 5 is rational. If 7 under root 5 is rational, so 7 under root 5 should be equal to P over Q, Q not equal to 0. So when we do, so under root 5 will be equal to P over 7Q. Now when you take up the right hand side is root 5 and it is irrational. We know it is irrational under root 5. And the left hand side is P over 7Q. P, 7Q are all rational. Therefore, P over 7Q is also rational. So we see that an irrational number becomes equal to a rational, but this is not possible. Irrational number is not equal to rational number. Therefore, our assumption is wrong. What is our assumption is wrong. So I can say 7 under root 5 is irrational. It's not rational. We had assumed that it is irrational, but that is wrong. It is irrational. Prove that under root 5 is irrational. So here we assume under root 5 is rational. Now if under root 5 is rational, we can write under root 5 equal to a over b, where b not equal to 0, a and b are co-prime. Now when we square, we get 5 equal to a square over b square. So 5b square equal to a square. So from here I say 5 is, see here, a square equal to 5 into b square. This is a factor and this b square also is a factor. So I can say 5 is factor of a square and 5 is factor of a. So is 5 is a factor of a, I can write a equal to 5 into m. So now I'm going to substitute this a equal to 5 into m in the equation. I had the equation, I call this equation as 1 and this equation is 2. So in equation 1, which is given a square equal to 5b square, substitute 2 means substitute for a square equal to 5b square. For a square I'm going to put 5m, because here there's given that a equal to 5m. Now if I solve this, I get 25 m square equal to 5b square. Take 5 common out, and here I will get that b square equal to 5m square. So again I can say 5 is factor of b square, 5 is factor of b. So here I have 5 is factor of b and 5 is also factor of a. So a and b have common factor, and that is 5. Therefore a, b are not co-prime. But this contradicts our data. We said a and b are co-prime. Look up here. We said a and b are co-prime. But this is a contradiction. A contradiction. Now why did we get this contradiction? Because our assumption must be wrong. Therefore our assumption is wrong. What was the assumption? That under root 5 is rational. So under root 5 is not rational. Under root 5 is irrational. Hence under root 5 is irrational. There is a circular path around a sports field. Sonia takes 18 minutes to drive around the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So first we have Sonia, and for every one round she takes 18 minutes. So if I have like one round here, one round will be 18 minutes, 2 rounds will be 36 minutes, 3 rounds will be 54 minutes, and she'll go on. These are all tables of 18. Have you seen? For first round is 18 into 1, second round 18 into 2, third round 18 into 3. Now let's go and see what happens to Ravi. Now Ravi, for the same circle, he goes a little faster and it takes 12 minutes. So for one round, after one round, 12 minutes one round, 2 rounds 24, and 3 rounds 36, and it goes on. Now when will they meet? I have already written the answer, but you see they will meet at 36, right? So this is common. So actually 36 is the LCM of 18 and 12. So you'll say let them meet at x minutes. So x is multiple of 18 and x is also multiple of 30 of 12, not 36, of 12. So therefore x is the LCM multiple, least common multiple of 18 and 12, and you find the LCM of 18 and 12, that will be 36. So the answer is they will meet after 36 minutes. However, Ravi would have taken 3 rounds by then, and Sonia would have taken just 2 rounds. Express as the product of its primes. So 5, 0, 0, 5. We'll divide this first by 5. Be 1, 0, 0, 1. Next, we now divide by 7. You get 1, 4, 3. Here we can divide by 11, and that will be 13. So 5, 0, 0, 5 equal to 5 into 7 into 11 into 13. This is an interesting number. It is a product of all prime numbers. All its factors are prime numbers. 5 is prime number, 7, 11 and 13 also. Find the LCM and HCF of 24, 36, 72 by prime factorization. So first 24 can be written as 2 raised to 3 into 3. Then we get to 36. 36 is 2 raised to 2 into 3 raised to 2. And 72 will be equal to 2 raised to 3 into 3 raised to 2. Now to find the HCF, we write the common factors, and these are common factors. If you say there is 2 in all 3 and there is 3 also, and we write the lowest power. The lowest power of 3, you see there is here 3, 2 and 3. The lowest power is 2. And when it comes to 3, the lowest power is 1. So 1. So HCF equal to 2 raised to 2 into 3, and which is 12. Now for LCM, all factors. And here we have factors 2 and 3. And highest power. 2, the highest power of 2 is here, 3. The highest power of 3 is 2. So LCM is 2 raised to 3, 3 raised to 2. That is 8 into 9, and it is 72 is the LCM.